Hello everyone, welcome to the channel SRS. This is Sumit Roy and we'll study sequential logic today. We'll discuss the basics of latch and flip-flop and then we'll enter the different types of flip-flops. So let us begin. Sequential logic. So in sequential logic, the basic sequential logic starts from a latch. And there is something about latch, there is some drawbacks with latch, so that we move on to flip-flop. So that is the basic part. But we'll study latch first, see the drawbacks and then we'll proceed. For an instance, I'll take it for granted that D flip-flop or D latch is known to all. Even if it is not known to all, I'll just explain it. What is a D latch? Because it will be easy for us if we understand D latch, and based on that we'll proceed to flip-flop. So what is a D latch? D latch is nothing but a buffer. Whatever is the input, same is the output with the required delay. With whatever be the delay, same input will be same output. So it's just a buffer. So D latch is nothing but a buffer. So based on this, we'll construct D latch input and D latch output, and based on that also D flip-flop output also. So I'll draw the diagram, I'll draw the input and time clock diagram, and then we'll see. So this is it. Let the clock be this. Now it is Q latch Q flip-flop. D flip-flop is something like this. That is, this is D input. This will be clock. This is a reset button, reset or reset N, I'll tell you later. And this is Q output. This construction is for latch as well as for flip-flop. I'll not get inside this later. I will get inside this. So this is a diagram, this is clock and this is D input. So obviously it's a sequential circuit. It will be with a clock input. Clock input is must. Now Q latch, that is Q output for this D only. So what is the output for this D latch when it is acting as latch is, it remains on, or it acts as buffer only when the time clock is high. Again I'll repeat it, that is Q latch, that is output of a latch will work, that is D will act, D flip-flop or D latch will act as a latch or as a buffer only when this clock is high. So as we all know, that is, it will only copy and paste it during the high position. So when it is high, this is the part when it is high. So nothing to worry about, copy and paste it. So this will be as it is, copy and paste it. Now here is the catch, that is, if it is ending with 0, that is low level, it will continue as low level when the clock is low. It cannot change during low clock, it cannot change. So if it finishes at high, it will continue as high. If it finishes as low, it will continue as low. Then again, now again it is high. So only copy and paste it. This whole thing is copy and pasting. Copy and paste. So this is something like this. Copy and paste it. Now it is ending at high. This is off. So carry forward. That's all. Now again, copy and paste it. So this is copy and paste it. Again it is high, so it will be continued as high. Then again it will be copy and pasting. So it will be in that manner. So this is very easy, very simple stuff. And obviously during this clock pulse, whatever it is storing or executing the output as whatever it is at the input, it is at the output. This is latch. It's good, no problem with this technique, no problem with this device, but there may be a problem. When there may be a problem? When there is noise in the environment, when there is non-required input in the environment, which can act as an input, obviously, noise. So the problem starts when there is noise. So let me insert some noise, very high frequency noises. Wherever it may be an industrial environment, so noises can be anywhere. I'm also taking noise as high as this and low as on-off signaling only. So it means voltage levels also can vary. So I'm not getting into that only. That is what I'm saying is there are noises, those are available now. Now what will happen at Q when it is latch is it does not distinguish between what is your required input and what is non-required input. Noise is, of course, this is noise. It's not required. But it is not immune to this noise. It is whatever is at the input, it will copy it as it is at the output. So noise will also carry forward. Copy and paste this. If the noise is here, no problem. If this is here, then this also again there will be copy and paste. So noise is carry forwarded from input to output during latch operation. It becomes vulnerable to noise. There is no way to stop this noise. There is no way. Now here comes the improvement, because obviously noise has to be stopped wherever it is possible. So if noise is carry forwarded, then obviously it is not a good thing. Here comes a catch, that is, what about a flip-flop? When it is a flip-flop. Now flip-flop is something that is an improved version of latch. Okay, how it is an improved version of latch? Because it is much more immune to the noise. How it is immune to noise? See, it's a very simple phenomena. That is, now I'll see about the edges. Now I'm more concerned about the edges. What is happening at the edges? Earlier in the latch, we were concerned about whole edge, complete level, whole level. In flip-flop, we are concerned about the edge only. Again, I'll reframe it. The latch works during the complete level of the clock. So it is also known as level triggered devices. It is on during the whole time. Whole time it is on, whole time it is on, whole time it is on. So whole part it is copy and pasted. In flip-flop, it is on only for this instant. Only for this instant, only for this instant, only for this instant. So in VSDL programming, if we go through it, then there is a function that is known as clock tick event and clock equal to 1. Clock tick event means this is an event, it is considered this edge is an event, this is an edge, this is an edge. So during this edge, it is considered whatever is the input. Now during this edge it is 0. It is 0 means it is low level. So during the whole clock pulse, it will be low. It will not study anything else other than what is the input at the during the edge triggering, during the transition. And the transition happens in means few nanoseconds. So in this nanosecond, whatever it is, if it is 0 or if it is 1, whatever it is, it has to be one criteria only. Either it will be considered as 0, either it will be considered as 1. So if it is 0, even during the transition also, if it will be considered as 0 or 1. It has to be definitive. So if in this case it is 0. So whole clock it is, for the whole clock it is 0. Now during this edge, during this time means there is a noise in it. Okay, considering noise, but noise is also, it will be high or it will be low. Considering it is high, so whole clock it will be high. Now again during this edge also there is little bit, I'll change it so that it becomes more comfortable. Now during this transition, this is high. So this whole clock becomes high. Again, if we change it little bit, during this transition, this is low. So during whole clock, this will be low. So the output is decided based on the whole clock output. The complete clock output is based on what is the steady during this edge triggering, during this transition. That is, if it is 0, for the whole clock the output will remain 0. If it is 1, the whole clock the output will be 1. So this is the advantage, that is, even if now there are lot of noises, whole lot of noises. Other than this, there are noises. So the noise, it will be immune to noise because it is not carry forwarded. So that is the advantage, that is in flip-flop, it becomes immune to noise. So this is the basic difference between latch and flip-flop. Based on this latch and flip-flop, we'll move forward. That is, from now on, any device that is a D latch, D flip-flop, it can be referred to as a latch or a flip-flop based on the triggering part. That is, latch is a level triggered device and a flip-flop is an edge triggered device. That's the only difference. No difference in construction, nothing. Absolutely no difference in the whole construction. So we can refer any device as a latch or a flip-flop, but we prefer flip-flop because we'll utilize flip-flop much more than latch. So from now on, it will be referred as D flip-flop or SR flip-flop or JK flip-flop or any other flip-flop. So we'll start with the flip-flop, basic working of the flip-flop with characteristic table, everything from the next class. So this is all, and this is all for latch to flip-flop conversion. Not conversion, latch and flip-flop differentiation, distinguishing, and that is all. So consider subscribing. Thank you for now, and like, comment, share. Your comments, if there is any doubt, send it in the comment section. I'll try to answer most of them.